All right, let's start chapter 6. Chapter 6 is all about inequalities. A lot of the first lesson seems to be a little bit of review, and the reason for that is because it's algebra based in the beginning. So we're going to apply the properties when we have positive numbers and segments and measures of angles to what we know already using algebraic properties, only now we're turning them to inequalities. If A is greater than B and C is greater than or equal to D, then A and B sum is greater than B and D. Notice the qualification that it's greater than or equal to here. Very similar to the addition property. If A is greater than B and C is greater than 0, then the product of A and C is greater than the product of B and C, just as the quotient of A and C is greater than the quotient of B and C, as proven with algebra here all the way through, where C is the common term in each of those things there. If A is greater than B and C is less than 0, then the product of A and C must be less than the product of B and C, and the quotient of A and C is less than the quotient of B and C. This might seem like a transitive property. If A is greater than B and B is greater than C, then A is greater than C. The only problem with that is we could call it the transitive property of inequality, but instead it might just be beneficial to say it. And finally, if A is equal to B plus C and C is greater than 0, then A must be greater than C. Sort of a spin-off of the top part here, where instead of putting them together, we're actually pulling the terms apart and determining something about A and B based on the value of C. Right now, hit pause and answer questions 1 through 6 on your worksheet. Okay, the only theorem that we have in Lesson 6.1 is this exterior angle inequality theorem. That is what it's called. There's no shortcut. The measure of an exterior angle, as shown in red, is greater than the measure of either of the two remote interior angles. Now we can deduce that from the fact that we know the exterior angle equality theorem is the sum of these two put together. So therefore the exterior angle must be greater than only one of them, because it's equal to both of them combined. Based on that theorem, we can apply some proofs. Take a second and answer the following as best you can using the properties and the following exterior inequality theorem. See if you can prove that the measure of angle 2 is greater than the measure of angle 4. Hopefully you have the given. From there, we could also conclude that the measure of angle 1 is greater than the measure of angle 3. Angle 1 is the exterior angle of this triangle right here. From there, we can conclude, because 1 is the exterior angle and 3 is the interior remote angle, 1 is greater than 3. The measure of angle 2 is greater than the measure of angle 3. One of the properties of inequality. Can you figure out which property that is? Step number 4, angle 3 is congruent to angle 4, vertical angles theorem. And then finally, we said because of that the measure of angle 2 is greater than the measure of angle 4. So not only can substitution be used for an equality piece, because we obviously know that 3 and 4 are congruent, we can substitute in from 3 to 5. On your worksheet, there are 2 proofs at the bottom. Complete the back of the worksheet from 7 through 12 and have that prepared for tomorrow.